Hi students, welcome to My Teacher channel. God made the integers and all else is the work of man. This was a statement by Leopold Kronecker. A life is full of numbers and numbers accompany us throughout our lives. For example, we tell our age using numbers. We measure our income using numbers. And also we measure our wealth. Numbers play a vital role within the realm of mathematics. In this chapter, we are going to explore the notion of numbers. Students, let us consider a simple division of numbers. Say 7 divided by 2. A pretty simple division. 2 divides 7 in this way. 2 3s are 6 and the difference is 1. Now what these terms are called? What is 7 called in this division? 7 is called as dividend. Yes, let me write here. It is dividend. And what is 2? Yes, it is called divisor. And this number 3 is called quotient. Yeah. And this 1 is called remainder. So let us derive a relation between these terms, dividend, divisor, quotient and remainder, like this. See here, 7 can be obtained by multiplying the divisor and quotient. 2 3s are 6 and adding the remainder plus 1. So 6 plus 1 is 7. So 7 is equal to 2 into 3 plus 1. Isn't it? 7 is equal to 2 3s are 6. 6 plus 1 is 7. Absolutely correct. That means dividend is equal to divisor into quotient plus remainder. So this is the relation. Dividend is equal to divisor into quotient plus remainder. Let us assume dividend as A and divisor as B. So for any two numbers or integers like A and B, dividend and divisor, we can find two more numbers or integers like quotient and remainder, and let us name them as Q and R. So dividend is equal to divisor into quotient plus remainder, where A and B are any two integers, dividend and divisor, and Q and R are integers called as quotient and remainder. Now let us once again see the division. Look into this division. Here the remainder is 1. Is the remainder lesser than the divisor? Means, is 1 less than 2? Absolutely. So here the remainder R must be less than B. And sometimes we may get the remainder 0 or more than 0. But always the remainder will be lesser than the divisor. So the condition will be like this. So remainder must be always greater than or equal to 0 and less than B. Or 0 is less than or equal to R less than B is the condition. And this rule is called division rule. So in the previous example, we have seen, or we came to a conclusion that for any two positive integers A and B, we can find two more integers Q and R, which satisfies the relation A is equal to BQ plus R, which is nothing but the division rule. dividend is equal to divisor into quotient plus remainder. So let us see some more examples. So in our textbook, the problem is given like this. Find Q and R for the following pairs of positive integers a and b satisfying a is equal to bq plus r. Now here we got 4 pairs of positive integers and we have to find 2 more integers q and r which satisfies the given relation. Now let's see. A is equal to 13 and b is equal to 3. A is equal to bq plus r is the relation. Now a value is 13 is equal to b value is 3. Now how many 3's are there in 13? Yes, 4 3's are there. 3 4's are 12. And see, 3 4's are 12. But the number is 13. And 3 4's are 12. What will be the remainder? Yes, it is 1. So 3 4's are 12 plus 1 is 13. Now for A13, B3, we found 2 more integers Q and R as 4 and 1. So Q is equal to 4 and R is equal to 1. We'll move to the second one. Pretty simple one. A value is 80 and B value is 8. And the given relation is A is equal to BQ plus R. A is 80 is equal to B is 8. So how many times? 8 10 times. 8 tens are 80. 8 tens are 80. So what is the remainder? Nothing. It is 0. So plus 0. Now for any 2 integers A and B means 80 and 8. We have found 2 more integers Q and R means 10 and 0 which satisfies the relation A is equal to BQ plus R. Here Q is 10 and R is 0. We'll move to the third one. A value is 125, B value is 5. Now given relation is A is equal to BQ plus R. A 125 is equal to B 5. So how many 5's are there in 125? 5 2's are 10, 2 left, 2 5 25. 5 5's are 25. So 5 25's. 5 25's 125. So 5 25's 125. We got the dividend value. So what must be the remainder? Yes, it is 0. There will be no remainder in this. Now we'll move to the fourth one. A value is 132, B value is 11. Given relation is A is equal to BQ plus R. Means 132 is equal to 11 into. So how many times? 11 12's are. 11 12's are 132. So it is completely divisible. Remainder is 0. Here Q value is how much? B value 11, Q value is 12 and R is 0. So from these examples, we can again further confirm that for any given 2 positive integers A and B, there exists 2 more integers or 2 more whole numbers Q and R which satisfies the relation A is equal to BQ plus R. So the results what we obtained from the previous examples leads to the theorem 1.1 called as division algorithm. So what is division algorithm? Let's see here. Given positive integers A and B, there exists unique pair of integers Q and R satisfying A is equal to BQ plus R where 0 is less than or equal to R less than B. In other words, R is greater than or equal to 0 and less than B. So this division algorithm or this result was first recorded in book 7 of Euclid's elements. Since it was mentioned in Euclid's Elements, it is called Euclid's algorithm, also division algorithm or Euclid's division lemma. And generally, this algorithm is used to find the highest common factor or HCF of any two positive integers. So by using Euclid's division lemma, let us find the HCF of some given numbers. See, the first one is like this. The given numbers are 70 and 50. So let us find the HCF of 50 and 70. By Euclid's division lemma, A is equal to BQ plus R, where 0 is less than or equal to R less than B. That is the condition. Now, take A value. Generally, A will be greater than B. So, here you take A is equal to 70 and B is equal to 50. Now, substitute in that. That implies A value is 70 is equal to, divisor is B is 50. Now how many 50s are there in 70? 50 ones are 50. So 50 ones are 50. How much left? Out of 70, 50 we got. The remainder is 20. Yes. Is the remainder 0? No. So what we do is we further apply the division lemma on 50 and 20. Until this will continue till we get the remainder 0. Now let's take A is equal to 50 and B is equal to 20. Now A is equal to BQ plus R is the condition. That means 50 is equal to 20 into, so how many times 20? 21s are 20, 22s are 40, 3s are 60, which is more than 50. So 22s are 40. Out of 50, 40 gone. How much left? 10. So that 10 is the remainder. Still, the remainder is not equal to 0. So what we'll do? We'll apply the division lemma on 20 and 10 till we get the remainder 0. So we'll continue this process till we get the remainder 0. Let's take A value 20 and B value 10. See here. So the condition is A is equal to BQ plus R. That means 20 is equal to B value 10 into how many times? 10 2s are 20. Perfect. 10 2s are 20. 20 out of 20 we got. So what is the remainder? Yes, the remainder is 0. Here remainder R is 0. Therefore we found the HCF of the given numbers 50 and 70 as, so what is the divisor that we got in the last step is the HCF. So 10 is the HCF. So the second one is like this. The given numbers are 96 and 72. Let us find HCF of these given numbers using division algorithm. So by Euclid's division lemma. What is Euclid's division lemma? A is equal to BQ plus R, where 0 less than or equal to R less than B. See here, let me take A value as 96 and B value as 72. Generally, A will be greater than B. So, how many times 72 goes in 96? Just one. 72 ones are 72. Out of 96, 72 got. How much left? 6 minus 2, 4. And 9 minus 7, 2. Is the remainder 0? No. So what we have to do? We have to continue applying the lemma on these two. So take A is equal to 72 and B is equal to 24 and apply the lemma again. How it will be? A value is 72, that is equal to B value is 24. 24, yes. So 24 ones are 24, 24 twos are 48, 24 threes are 72. And the remainder is 0. Great. So we got the remainder 0. Here, remainder is equal to 0. So HCF of the given numbers 96 and 72 is. So in this step, what is the divisor? That will be the HCF. Divisor is 24. That is the HCF. And third one is like this. 300 and 550. We have to find HCF using division algorithm. See, let me apply division algorithm, Euclid's division lemma. What is that? A is equal to BQ plus R, where 0 less than or equal to R less than B. Great. Here, A value is 550 and B value is 300. Students, need to be little careful. Whenever you take A value, it must be bigger than B. So bigger value has to be taken as A. Great. Now apply here. 550 is equal to B value is how much? 300. 300 into, how many 300s are there in 550? 300 ones are 300, 300 twos are 600, which is more than this. So 300 ones are 300. Out of 550, 300 is subtracted. So what is the remainder? Yes, it is 250. Now the remainder is 250. Is it equal to 0? No. So we have to continue. Then take A value as 300 and B value as 250. And further apply the division lemma. A is equal to BQ plus R. That means 300 is equal to, B value is 250 into 250 ones are 250, twos are 500, which is more than this. So 250 ones are 250. Out of 300, 250 gone. So remainder is 50. Still we did not get a remainder 0. So we'll continue. Now take A value as 250. This one will be A and this is B. B value as 50. Now continue. Which equals to 250 is equal to 50 into, see here, how many 50s are there in 250? Yes, 5. So 55s are 250. So we are getting remainder 0. Here R is equal to 0. Therefore, HCF of the given numbers 300 and 550 is, what is the divisor here? 50. The fourth pair of integers are like this, 1860 and 2015. Students need not to worry by seeing such big numbers. So there is a short way. What is that? We can find the HCF in our regular method, division method, and then you can write the lemma or the algorithm later. So in rough column, let us find the HCF of these two numbers. Right, 1860 and 2015. So with 1860, divide 2015. Quite natural, 1860 ones are 1860. And what is the difference? 5 minus 0, 5. 11 minus 6, 5. 9 minus 8, 1. 1 minus 1, yes. Now 155. Is the remainder 0? No. So we have to continue the division. Now divide with 155, divide 1860. Yes. Now 155 tens are 1550. It is more than that. So you try 155 12s are 12 5s are 60. Great. 12 5s are 60 plus 6, 66. 12 1s are 12 plus 6, 18. So 155 12s are 1860 and the remainder is 0. So the HCF will be 155. Now let us write the algorithm here by Euclid's division lemma. What is the condition? A is equal to B cube plus R, where 0 less than or equal to R less than B. Now take A value, the bigger number is taken as A value, 2015, and B is 1860. Now let's see here. A is equal to B cube plus R. That means 2015 is equal to 1860. How many times? 1860 ones are 1860 ones are 1860. And what is the remainder we got? 155. So plus 155. So the step became easy. Now take A value as 1860 and B value as 155. Now continue the lemma. 1860 is equal to 155 into how many times? 155 12s are. 155 12s are 1860 and the remainder is 0. So plus 0. Then since here R is equal to 0, therefore the HCF of given numbers 1860 and 2015 is the divisor in the last step will be the HCF. So that is 155. Now let us see another application of Euclid's division algorithm. Example 1. See here. Show that every positive even integer is of the form 2q and every positive odd integer is of the form 2q plus 1. So we have to show that every even integer is in the form of 2q and odd integer is in the form of 2q plus 1. So to solve that one, what we'll do? See here, solution. Let A be any positive integer. So we are assuming that A is some positive integer and B is equal to, see what we have to show? We have to show that even integer is in the form of 2q. So the coefficient there is 2. So whatever the coefficient that they keep, that has to be taken as the value of B. So B is equal to 2. So we are assuming that A is any positive integer and B value is 2. Then by division algorithm, what is division algorithm? Yes, A is equal to BQ plus R, where 0 is less than or equal to R is less than B. That means R value is equal to 0, R greater than 0 and less than B. This is division algorithm. See here, if R value lies between 0 and B, what is B? Yes, B value is 2. Then R will be, see, it is equal to 0 or greater than 0. Greater than 0 means after 0, 1, and less than B. Less than B, what is the B value? 2. So it should be less than 2. Then R must be either 0 or 1. Then if R is equal to 0, then apply the division algorithm. A is equal to, B value is how much? 2. Q plus R value, we are taking it as 0. So A becomes 2q. See, a value is 2q means it is a multiple of 2, or in other words, it is completely divisible by 2. Then this number will be an even integer. Is even integer. Equation number 1. Why? Because this is completely divisible by 2, so it becomes an even integer. Then we have taken r value as 0 in the first case. In the second case, we are taking r value as 1. If r is equal to 1, then by division algorithm, a is equal to bq plus r. A is equal to b value 2q plus r. R value is 1. Here, is this completely divisible by 2? No, because we are getting remainder 1. So the number which leaves remainder 1 when it is divided by 2 is called an odd integer, because all the positive integers are either even or odd. If 2q is even, then 2q plus 1 becomes odd. Therefore, 2q plus 1 is odd integer. Here is the second example, and it says, show that every positive odd integer is of the form 4q plus 1 or 4q plus 3, where q is some integer. So we have to show that every positive odd integer are in this form. Either it is in the form of 4q plus 1 or 4q plus 3. Now, to show that one, what we do first? We will assume that let a be any positive integer. So a is some positive integer and b is equal to, what we have to take b value? Yes, 4. So whatever they give in this, that number has to be taken as b. Now by applying division algorithm, on a and b, how it will be? What is division algorithm? A is equal to bq plus r, where 0 is less than or equal to r less than b. Let me write here. A is equal to bq plus r, where 0 less than or equal to r less than b. So a is equal to b. What is the value of b? Yes, 4q plus r. What are the values of r? The possible r values are, it is like starting from 0, 1. It should be less than b. What is b value? 4. So less than 4. 0, 1, 2 and 3. That's it. Because it should be less than 4. If r is equal to 0, let me take the first value. Then a is equal to 4q plus r, means r value is 0, which is equal to 4q. Now, is this divisible by 2? Yes. Let's see here. Into table, 2 2s are 4q. So it is completely divisible by 2. That means it is even. A is even. But if r is equal to 1, then what will be the a value? A is equal to 4q plus r value is how much? 1. Now, is this divisible by 2? No, it is not. That means it is leaving remainder 1. How? See here. A is equal to, into table, 2 2s are 4q, but 1 is the remainder. A is odd. Equation number 2, and this is 1. So odd is in the form of 4 cube plus 1. Next, the last possible value. If r is equal to 3, then a is equal to, what is a value? 4 cube plus r. 4 cube plus r value is 3. Let's try to divide with 2. A is equal to, take 2 common. 2 2s are 4 cube plus 2 1s are 2, but 3 is there. 2 1s are 2, that means 1 is the remainder. See, since we are getting remainder 1 when it is divisible by 2, it is odd integer. A is odd, and this is equation number 3. Therefore, every odd integer is of the form, this is even, but odd are in which form? 4 cube plus 1 or 4 cube plus 3. 4 cube plus 1 or 4 cube plus 3.